Now we will do what we promised on the previous page, where we're going to review type 1 and type 2 errors. On the previous page, we talked about how we need to review this. We reviewed p values, what the meaning of them was, but now we're going to review what type 1 and type 2 errors are. We know that statistical inference is based on probability, so there's always some chance of making a wrong decision. Recall that there are two types of wrong decisions that can be made in hypothesis testing. When we reject a null hypothesis that is true, we commit a type 1 error. When we fail to reject a null hypothesis that is false, we commit a type 2 error. So a type 1 error, like I said, it's how we rejected a null hypothesis that is true. That's like saying an innocent man is guilty. You know, we said innocent until proven guilty. And innocent. Yeah. But on the other hand, type 2 errors are saying the guilty man or woman is innocent. So type 1 error, you're saying an innocent man or woman is guilty. Type 2 error is like a guilty man or woman is innocent. So you're making a mistake either way, but what kind of mistake is it? So back to the context of the hypotheses. When we reject the null hypothesis that is true, so we say an innocent person is guilty, that's a type 1 error. When we fail to reject the null hypothesis that is false, so someone's guilty and you say they're innocent, then that's a type 2 error. The following table summarizes the logic behind type 1 errors and type 2 errors. If the null hypothesis is false and we reject it, that's good. That means we made the correct decision. If the null hypothesis is true and we fail to reject it, that means we say it's fine. We made the correct decision. But if it's actually true and we reject it, that's a type 1 error. If it's actually false and we don't reject it, that's a type 2 error. So we missed something that's false. If it's a type 2 error, we said something was false when it's actually true, that's a type 1 error. Anyway, it's possible to have some influence over the likelihoods of committing these errors. By decreasing the chance of type 1 error, it increases the chance of a type 2 error. We have to decide which error is more serious for a given situation. Sometimes a type 1 error is more serious. Other times a type 2 error is more serious. Sometimes neither is very serious. Depends on the context. Recall that if the null hypothesis is true, the probability of committing a type 1 error is alpha. Why is this? Well, when we choose a level of significance alpha, we are choosing a benchmark for rejecting the null hypothesis. If the null hypothesis is true, then the probability that we will reject a true null hypothesis is alpha. So the smaller alpha is, the smaller the probability of a type 1 error. It's more complicated to calculate the probability of a type 2 error. The best way to reduce the probability of a type 2 error is to just increase the sample size. That seems to be our answer to a lot of problems in this class, right? If you got a problem, just increase the sample size. But once the sample size is set, larger values of alpha will decrease the probability of a type 2 error while increasing the probability of a type 1 error.